you're going to have to be able to, first of all, know how to find the area of a circle. So you have to know the formula. This one won't be written down. You just should know it, but this one you should know from heart. So it says, what's the area of the circle? So first of all, you say to yourself, okay, I know area of a circle is pi r squared, right, everybody? So area of a circle is pi times the radius squared. So if you're given the radius is 6, then to find the area, won't you just plug that in? So area is equal to pi times 6 squared, right? So that would be 36 pi, because we write our answers in terms of pi if at all possible. Right, everybody? So that's pretty easy. Now it says, what's the area of the circle? So this time you're given the circumference is 12 pi. So you say to yourself, okay, well, I know that I'm looking for the area, which is pi r squared, but I don't know the radius. So I've got to figure out a way to find the radius how. Well, if we're given the circumference is 12 pi, you say, okay, so I know that circumference is equal to 2 pi r, right? Circumference is 2 pi r. So if we're given the circumference is 12 pi, then we know this is 12 pi is equal to 2 pi r, right? We're given the circumference. So then we can find the radius, given that the circumference is 12 pi. So solving for r, we divide by 2 pi to both sides, which would be 6 is equal to r. So now we know our radius is 6. So once again, area of a circle is pi r squared. So we know area is pi times 6 squared, which is 36 pi. So depends on how the question's asked. It might just give you the radius, so then it's really easy. If not, it's not that hard to figure out the radius, right, everybody? Okay. Okay, so now finding the area of a sector. This will be the next thing that you'll be asked to find. So find the area of a sector. Now remember, area of a sector means area of a section of a circle. So you know that the area of a full circle is pi times radius squared, right? Now area of a section of a circle is saying it's just take the section divided by the full circle times by pi r squared, right? Everybody? So it's pretty much the same thing. It's just you're only considering that you're only taking that piece. So, okay, so in this one we're given the radius is 3 and the arc is 30 degrees. So we can just plug that right in. So our area of our sector, we're only looking at a 30-degree piece of the full circle. So 30 degrees divided by 360 degrees times by pi times by the radius squared. And we're going to write it in terms of pi. So just type it in your calculator. You don't type in the pi part or else your calculator won't be able to change it back to a simplified fraction. So 30, I'm going to just type it in like this. There's many different ways. 30 times 9, because that's 3 squared. So we have 270 divided by 360, and I get 0.75. I change it back to a fraction. That's 3/4. So our area of that section will be 3 pi/4. Do I need to go through the simplification of that? I think you guys are good with that, right? It's just calculator typing in, changing it back to a fraction. Okay, so given this time, we're given a diameter is 10, and then we're trying to find the area of this sector, this section of the circle. So we're only looking at finding the area of this section of the circle. So that's 65 degrees. So we know we're going to do 65 degrees divided by 360 times by pi times by radius squared. What's the radius if the diameter is 10? 5. So pi times 5 squared. So now I'll type it in. 65 times 25. And then divided by 360. You get a decimal, change it back to a fraction. It's a hideous fraction, but that's okay. So area is equal to 325 pi over 72. That one didn't come out very pretty, but we did the math right, so we're okay. Questions on how to find the area of a sector. Okay, not much harder than area of a circle. Pi r squared, yes.
Are you going to put these equations up for?
Nope, you've got to know them, but there's only 3 that you have to know. Circumference, which is 2 pi r, right? Area of a circle, pi r squared. Area of a section of a circle, same thing as pi r squared. It's just you consider that you're only taking the section. So the section divided by the full circle, that's why theta divided by 360 times by pi r squared. So what you could do is when you first get the test, the first thing you do is go to the top of your paper, write down those 3 things. So that if you need to refer back to them, you can. If you're doing it from memory, that's not cheating, right? That's exactly what I do. Every time I get a test, even the ACT, the first thing I do is write down a bunch of formulas so that I don't have to, if I forget, I can refer back to them. Does that make sense, everybody? Okay. Awesome. But you will be able to use your own theorems, your own theorem sheet. You know the theorem sheet? So if you want to get that out right now, it'd probably be good to have that out so you can like get your eyes looking in the right spot. Okay, so get out your theorem sheet. It'd probably be good for you. Okay, so let's go through the first part of the test still. You're going to be asked, first of all, those first two questions, finding area of a circle, finding area of a section. Now we're going to go through, we're going to be given a circle with some central angles, and we're going to go through and answer these questions. So first of all, these are all central angles, you guys, because see how it starts at the center of the circle and works its way out. So these are all central angles. So we know that central angles equal their intercepted arc, if we know they're for sure central, and what they are. They start at the center and work their way out. Okay, so it's saying name the major arcs here. E is supposed to be right here. I couldn't put it up. So some major arcs. Remember, a major arc intercepts a minor arc. It eats a minor arc, and a major arc needs to have 3 points. So I always start out and say, okay, where are my minor arcs? So like this is a minor arc, right? So a major arc would be A, E, B, or A, D, B. It doesn't matter how you state it. Does that make sense?
So it's practically everything but.
Well, I mean, it has to start on A and end at B, but the other point you specify with a major arc doesn't matter. Does that make sense? Because it's the same thing. So I'm just going A, D, B.
Could be AED.
And it could be B, you're saying going the other way?
Like, could it be like AED instead of C and B too?
A, E, B? Yes.
Not to D.
Oh, to D. Well, that's a different arc, right?
Would that not be a major?
No, because that doesn't eat a specific minor arc. Yeah, so that's why I always draw out my minor arc. So here's a minor arc, right? So now I'll do a major arc to name it. So it'd be like B. It has to start at B, right? And end at C. But B, A, C would work, right? There's many others that would work there. But so B, then to A, then to C, because we're starting here and ending here, going around the circle. Another minor arc would be this. So a major arc would be C, B, E, right? That's one. C, B, E. And then we're getting there. This is a minor arc. So E, A, D works.
Wait, wouldn't that be CBD?
Well, this is a minor arc, right?
Well, I mean on the last one. On the green one.
On the green one, C. Oh, did I say E? Yeah, it would be. We would have stopped at D. Yeah, that wouldn't have been right.
So does it have to be less than 9 degrees?
No. No. So this one would still be a minor arc. We'll get there. Yeah. So then with this next one, then like D, B, E works, right? D, B, E. It's early. Okay. D, B, E. And then right here is also a major arc. Minor arc from here to here. So AE is a minor arc, so a major arc would be eating it, right? So EDA would work. Does that make sense, everybody? Okay, sweet. So I've named all the major arcs. Okay, circumference of this. And you'd have to know the radius, and it would be given. So I'm going to do radius of 2. So if you're given that the radius is 2, you'd say, okay, I know circumference is 2 pi r. So circumference is 2 pi times the radius. Now, let me help you make sense of why that formula is what that formula is, guys. 2 pi means the full circle, right? And then you got to consider the radius, right? So that's taking 360 times by the radius, which that's in just radians, right? Because remember, circumference means physical distance around the circle, right? So does it make sense of why the circumference of a circle, you would take the full edge, the full outside, which is 2 pi, then you'd multiply by the radius, because it's not a radius of 1, right? So 2 pi times 2. So 2 pi times 2, which is 4 pi. You'd leave it in terms of pi. So our circumference of this circle is 4 pi. That's the physical length around the circle, right, everybody? Okay. Now it says, what's the length of AD? So what's the length of AD? Now remember, if you're dealing with like a picture like this, I'll just accept the actual degree. You don't have to find the physical length if you're given a picture like this. Because more so, I probably should have said find the measure of arc AD. Because remember, measure versus length. Okay? So you could do both if you wanted to make sure you get it right. So the measure of AD would be, okay, so starting from A to D, so from A up to D. We want to know from there to there. So we've got to add some things up, right? Isn't this arc from here to here 180 degrees? Isn't that halfway around the circle, guys? So this is 180 degrees. Well, if that's 180 degrees, isn't the arc 180 degrees since it's a central angle? And if this is 30 degrees, isn't this arc 30 degrees since it's a central angle? So to find that arc, you would do 180, right? 180 plus 30 is 210 degrees. So the measure of arc AD is 210 degrees. Is everybody comfortable with that? Now, if I wanted to know the physical length, wouldn't I have to go 210 degrees divided by 360, right? And then times by pi times by r, right? Okay, so if you wanted to know the physical length of that, we'd say, okay, we know length of an arc is S is equal to R times theta, where S stands for arc length, right? So we'd have S is equal to our radius, which is 2, times theta, which is 210 degrees. But we don't have, if we're finding physical length, we can't have it in degrees, or else that's going to be in degrees. So that's why we change it 210 degrees to radians. How do you go from degrees to radians? You said radians second, right? So that's what goes on top. So you multiply by pi over 180. So now you just multiply that in your calculator, not putting in the pi, right?
Why is it 180 and not 360?
It's not, because remember that this is how we change from degrees to radians, no matter what, right? It's pi over 180. So we have 210 times 2 divided by 180. Change it back to a fraction. That's 7/3. So the length, the physical length of the arc is 7 pi/3. Does that make sense, everybody? So the measure of the arc was 210 degrees. The physical length was 7 pi/3. Does everybody understand the difference between the two? Do you have questions? S is equal to R times theta. That's the length of an arc.
So, when you're asking length, that's the answer, not 210.
Yeah, I put both, but like, if I said find the measure of arc AD, it's just 210. If I say find length, that means physical length, right? So I would just put both, because like, really, that is the measure of the angle, but this is the physical length. You know what I mean? I just put both. Okay, so it says find the length of the highlighted arc. Okay, so find the length of the highlighted arc. Because we're talking length, we have to say, okay, we know length of an arc is S is equal to R times theta, right? Physical length of an arc. So looking at this arc here, what kind of, we have 30 degrees. What would this piece of the arc be? 180 degrees. So we know that S is equal to our radius, which is 3, right? 3 times theta, so 180 plus 30, which is 210, right? So 210, that's R times theta. We'll change 210 to radians. So we'll multiply by pi over 180. So then, you know, we just got that answer, right? It was 7 pi/3. We just got that same one. So our length of our arc is 7 pi/3. Okay, let's do this one. So once again, we're asked to find the length of the highlighted arc. So here's our highlighted arc. If this is 40 degrees, it's a central angle. It starts at the center, works its way out. So this arc is 40 degrees, right? Everybody? So then we know S is equal to our radius, 4 times theta, which is 40. We'll change it to radians, so multiply by pi over 180. Go, type it in, let's go. So 4 times 40 divided by 180, change it back to a fraction. Yep, 8 pi/9. So 8 pi/9. That's the physical length of that arc. Is everybody comfortable with those ones? Yes? Okay. Okay, so it says find the value of each variable. Lines that appear to be tangent are tangent. So there's going to be a lot like this, so every problem is going to be different. You're going to look at your theorems list. Can I borrow mine back again for a sec? So you're going to have your theorems list. You're going to be using all of these theorems depending on what you're given in each picture. So let's go through, and I'm going to kind of help you think through what you're given in each picture. So everybody look at this picture. So first of all, we have a line that's tangent. Isn't this the line of tangency? Now look, because this radius is being dropped straight to the point of tangency, does everybody see that? We know for sure this is 90 degrees, correct? Now look, what are we finding here? We're finding a physical length, right? So this is just right triangle. So now think to yourself, okay, so I have to set up right triangle Pythagorean theorem since we're finding side lengths, right, everybody? We're good with that? So you have to say to yourself, okay, if this is 3, wouldn't this also be this radius be 3? Isn't a radius no matter where it's drawn 3? Everybody good so far? So now set up the Pythagorean theorem correctly. Side 1 squared plus side 2 squared is equal to the hypotenuse squared. Hypotenuse is across from the 90-degree angle. That has to be in that part of the equation. So our hypotenuse, I'm going to write it out like this for myself. Wouldn't it be a plus 3? Everybody. Okay, so we know side 1 squared, 4 squared, plus side 2 squared, which happens to be 3 squared, is equal to the hypotenuse all squared. So that whole hypotenuse is a plus 3 all squared. Is everybody good with that? So let's go ahead and just calculate that in our calculator. So you'll do 4 squared plus 3 squared is 25. So we have 25 is equal to, now this you've got to actually multiply out. Remember that that's a plus 3 times a plus 3. You can't just square each of those things. So if we double distribute very carefully, we'll get a squared plus, I'm going to combine all like terms. So plus 3a, which would be 6a plus 9. Is everybody good so far? That's equal to 25. Is everybody good? Now you say, I'm solving for a. That's my goal, right? Solving for a. So looking at this, it's quadratic, right? So we've got to solve using the, either solve by factoring if it's factorable, or solve using the quadratic formula. But first, we have to make sure our quadratic set equal to 0. So we've got to subtract 25 from both sides, right? Everybody? So we have 0 is equal to a squared plus 6a, and then negative 25 plus 9, negative 16. Okay, so I'm going to try solving by factoring because it's way quicker if you know how to factor. So, and there's a lot less room for error. 9 out of 10 people can't even do the quadratic formula correctly. So I'm looking for what multiplies to be a times c, 1 times negative 16. So what multiplies to be negative 16 and adds up to be 6, right? 8 times 2, correct? Which one's negative? The 2, right? And this quick factor, because our a value, which is in front of x squared, our a value is positive 1. Does everybody see that? Because our a value is positive 1, it's going to factor to be a binomial multiplied together with those two things. So I just put in my parentheses, I put my a in, or x, it doesn't matter, whatever variable is a variable, and then we plug those in. It was positive 8, so I say plus 8. It was negative 2, so I say minus 2, right? And since that's equal to 0, we can now set each of those equal to 0 and solve. So a plus 8 is equal to 0. Therefore, a is equal to, and a minus 2 is equal to 0. Therefore, a is equal to 2. So we have two answers, which makes sense. With the quadratic, you should always have two answers when solving. We would throw out the negative answer because this piece is obviously not negative. So we throw that answer out. We do keep, however, the 2, right? So a is equal to 2. There's our final answer. So that took quite a bit of work, didn't it? But you can do it. Okay. Sweet. Okay, let's go through and find, let me give myself some room. We're given this picture, we're asked to solve for x. Well, first of all, you guys look, we have a diameter drawn going through the center of the circle, right? Now look, isn't it hitting at a 90-degree angle here? Which means it's bisecting the sides. Okay, so bisecting means cut evenly, right? Is everybody good with that? Okay, so if this is 10, if this full length is 10, what's this? What's this? Okay, awesome. Now our full diameter is 12. What's a radius? So can I draw a radius from here to here?
Yeah.
So this is 6. Now if this is 90 degrees, won't this be 90 degrees? Won't this be 90 degrees?
Yeah.
Everybody good with that? Don't we just now have a right triangle we can solve for x? Right, everybody? So if you see a picture like this and there's a 90-degree angle, say to yourself, I'm going to drop a radius in a new spot right here. And then, you know what I mean? Use what information you have. So now it's just, remember the hypotenuse is across from the 90 degrees, so careful because this is our hypotenuse. So we'll have 5 squared plus x squared is equal to 6 squared, right? Everybody good? So I'm going to go, okay, I'm going to subtract 5 squared from both sides. So that's x squared is equal to 36, because 6 squared is 36 minus 25. Am I correct? So So 36 minus 25 is 11. So x squared is equal to 11. To solve for x, we'll square root both sides of the equation to get x alone. So we have x is equal to plus and minus. Now we will accept decimals on this one, so the second square root of 11, you get 3.3. Is everybody comfortable with that? So we get plus and minus 3.3. Would it make sense to have a minus? No, we throw that answer out. So x is equal to 3.3. Everybody good with that? Do not miss that one. These are that one's like probably the more easy one, right? As long as you know what you're doing. Okay, moving on. Okay, so let's look at our pictures, look at our theorems. Let's see what we're given here. What do we know? So first of all, remember, a central angle is equal to its intercepted arc. An inscribed angle is an angle that starts on the inside of the circle, works its way out as long as it's not starting in the center, right? And it has to hit on the outside of the circle somewhere. And an inscribed angle is half of the amount of its arc, right? So if its arc is 60, then the inscribed angle is 30. Okay, so let's look at these pictures and decide how we can solve these. What are we given? So first of all, looking at this picture, I say to myself, oh, I have a central angle, do I not? And I have an inscribed angle. I know a lot about those things, so I'm going to use those things to go ahead and fill this in. So we're finding A and B. So first of all, if this is a central angle, which it is, look, it starts from the center of the circle and works its way out. We know it's opening up on that arc, right? I sometimes draw big dots, so I can say, okay, I see the arc it's for sure opening up on. So if this is 50 degrees, what's A? 50. A central angle is equal to its intercepted arc. Is everybody comfortable? Now we look and say, okay, so now I'm looking for this angle. Well, this is an inscribed angle, we know, because it starts on the outside of the circle and it works its way out. Now I like to draw my dots. It's opening up on that arc. Does everybody see how it's opening up on that arc? What's the arc length? 50. So what would B be? 25. Take the arc, divide it by 2, so B is 25 degrees. Everybody comfortable with that? So every picture you're going to ask yourself, what information am I given? Because you'll be using that information to solve. Okay, so next picture. What information am I given? Well, I'm given an inscribed angle again, right? Because it starts on the circle and it's not on the center of the circle and it works its way out, opening on that arc from there to there. I always draw in my big dotted lines. So now we're solving for x. Well, an inscribed angle is half of its arc, so what would that be? 80, right? That times 2? 80 degrees. Are you guys comfortable with those two? Okay. Okay, let's look at these next two pictures. Tend to be harder ones for some people. So looking at this picture, you say to yourself, okay, what am I looking for? I'm looking for a segment length, right? Everybody? Now, this is not a diameter because it doesn't cross through the center of the circle. So if it was, and this was a 90-degree angle right here, wouldn't this just be 2? Because it would be bisected, right? But it's not 90 degrees. So, and it's not going through the center of the circle necessarily, but it has to be going through the center of the circle, a diameter, and 90 degrees. Okay, so you say to yourself, well, what theorem is that? Well, look at your theorems. Oh yeah, we did learn a theorem for that. You can find any length of a chord that's bisecting another chord, because we know that this times this will be equal to this times this, right? That's a theorem. So just set it up. 6 times 7 will be equal to, now make sure it's this part of the chord. Do you see how this chord continues? So it's not that they're equal, but I'm just saying make sure you set it up correctly. So 6 times 7 will be equal to 2 times y. Now it's just algebra solving for y. So we have 42 is equal to 2y. Divide both sides by 2, 21, right? So we get 21 is equal to y. Questions on that? Okay, next picture. Once again, you ask yourself, what am I given? So first of all, looking at the picture here, it does say in the instructions, lines that appear to be tangent are tangent. Doesn't this line appear to be tangent? Okay, now it's touching the circle in one spot. Now check for sure, because this only works if you're dropping from the center of the circle to the point of tangency. Do we start at the center of the circle, drop to the point of tangency? Yeah, right? Do you see how that's a radius, drop to the point of tangency? So we know for sure in that case that that's a 90-degree angle. Now you're saying to yourself, I have a right triangle, but I'm not finding side lengths. The Pythagorean theorem is only for side lengths of a right triangle. Well, we are finding angles. Well, we know angles of any triangle will add up to be 180, right? So you'll just take 180 minus 90 degrees minus 30 degrees. What do we get? 60 degrees. Very good. Questions?
That 30 wasn't the part.
No, so 30 was that angle. Yeah, good question. Okay, next couple. Like I said, there's just tons of problems like these where you just have to look and say, what am I given? Okay, so it says find the value of each variable. Lines that appear to be tangent are tangent. So looking at this, first of all, notice we have a tangent line here, right? Okay, but we're not dropping a radius down to that point of tangency, right? So we know these aren't necessarily 90 degrees. But looking at the angles, here's an angle, and here's an angle, right? Everybody? They're opening up on arcs. Well, aren't those still considered inscribed angles? Yeah, right? Remember that remember that these are still inscribed angles. So it's starting on the outside of the circle, right? And opening up on an arc. So this angle right here is opening up on this arc from here to here, right? So we know an inscribed angle is half of its intersected arc. Am I correct? So this is 200 degrees. What's this? 100, right? Everybody good with that? Now you say to yourself, I know that was this much of the circle. If that's 200 degrees, isn't a full circle 360? Okay, so we have 360, obviously, minus 200, which is 160. So isn't this 160 degrees? Is everybody comfortable with that? Now look, this is also an inscribed angle. It starts on the outside of the circle and opens up on an arc. So now we're looking from arc from here to here. So if we know the arc's 160 degrees, what would this inscribed angle be? 160 divided by 2. Okay, everybody good with that one? Okay, doing good. Okay, looking at this next one here. We're given a tangent line again. There's the point of tangency-ish, somewhere in there. And we have an inscribed angle right here, right? It starts on the outside of the circle and opens up on the arc. Now I like to draw it from here to here, right? This arc. So how do we find that arc? 150 times 2, right? So that's 300 degrees. The arc's 300 degrees from here to here, so what does that leave us for y? 60 degrees. 360 minus 360 minus 300 is 60. So then this is also an inscribed angle, so what would that angle be? 30 degrees. Which, look guys, if you notice, isn't this a straight line angle? Shouldn't it add up to be 180? Didn't it? Okay, we're good. And then these are straight line angles, shouldn't they add up to be 180? They did, so we're good. Okay.
So couldn't
Okay.
do that?
What? Yeah, you could have done that way too. Yeah, there's many different ways we can look at these. Okay, so find the value of each variable. Once again, lines that appear to be tangent are tangent. So look, isn't this a tangent line? Doesn't it start on the circle and work its way out? I couldn't draw it very perfectly. Right? There's a tangent line. Isn't this a tangent line? It starts on the circle, only hits once, and works its way out. Now those two tangent lines intersect. So we know if we have two tangent lines that intersect at one spot, which right here they're intersecting, then these lines are equal, right? Just keep that in mind. Now also, a couple things to remember. If we have a radius being dropped to the point of tangency, which we do, doesn't it make a 90-degree angle for sure? And so we're dropping to the point of tangency here, isn't that 90 degrees? Now a polygon, all of the angles in a polygon should add up to 360 degrees, right? So shouldn't we do 360 minus 90 minus 90 minus 170? Everybody? Doesn't that make sense? How we find x in that polygon? So 360 minus 90 minus 90 minus 170 is 10 degrees. So it intersects at a 10-degree angle. Questions on that? Okay. Sweet. Okay. Next one, moving on. Okay, this one's probably one of the harder ones, actually. Okay, so looking at this next picture here. So first of all, we're trying to find this arc. Now looking at this, we have no idea what this piece of the arc is, right? Now, also, we're only given segment lengths. Well, okay, so a couple things here. This is being dropped at a 90-degree angle, so won't it bisect that piece to the end that piece? So this is 5 and this is 5. Is everybody good with that? Now, can't we drop a sense, okay, so, let's see here. Okay, so can't we drop down this line, this radius, but we have no idea what the radius is, right? Okay, interesting. But we could, okay, so if we drop this down, we have two right triangles, right, everybody? Okay. Now, we don't have any idea what this is, but that wouldn't really help us anyways, what the radius is. That won't help us anyways, because we're trying to find this arc length. So this is what I want you to notice. Isn't this arc length, from here to here, a central arc to this central angle? Doesn't that central angle open up on that arc? Is everybody good with that? Okay, so if we knew that angle right there, wouldn't we know the arc's equal to it? So we're going to find the angle right here. So let's focus on just this triangle right here, and let's find angle theta. Now this is actually secondary 2 stuff. So if we have a right triangle, you guys, which we have a right triangle, we're trying to find theta, we have a 3 and a 5, right? Can we set up a right triangle trig ratio to find angle theta? So remember your 3 right triangle trig ratios that you should have learned in secondary 2. Sine of theta, cosine theta, tangent theta. Then this is the same that I teach my secondary 2 kids. Oh heck, so sine, cosine, tangent. So sine of theta, cosine theta, tangent theta. Oh heck, another hour of agony. So these are the 3 right triangle trig ratios that we can use, okay? Is everybody good with that? So then from theta, we're given the opposite and the adjacent, right? Opposite and adjacent. So we're going to be using tangent of theta. Does everybody understand what I'm saying here? So we're going to put in what we know. So we have tangent of theta is equal to opposite, which is 5 from theta, over adjacent, which is 3. Now we can solve for theta, right? Don't we have to get theta alone, and it's trapped in tangent. So in this case, you would take the inverse tangent of both sides. So we have theta is equal to tangent inverse of 5 over 3. Type it into your calculator. So you'll do second tangent of 5 divided by 3. 59 degrees. So theta is 59 degrees. Now make sure your calculator's in degree mode. Okay, it is. So if this is 59 degrees, won't this also be 59 degrees? Yeah, everybody? If this is 59 degrees, so will this angle be right there. I'm going to point at 59 degrees. So now if you add those up, you'll have that full angle from here to here. So you have 59 plus 59, 118 degrees. So if that's 118 degrees, then that's a central angle. Won't this be 118 degrees? Okay, questions on that? That was probably the hardest one on there. Just because it's different. And yeah. Okay, so next pictures here. We're almost done. We're getting there, guys. Stay with me. So it says find the value of each variable lines that appear to be tangent or tangent. So first of all, if you look at this picture, you say to yourself, what am I given here? I'm given a chord and a chord, right? It makes an angle on the outside of the circle, right? Now, there are theorems that go along with something like this. So look at your picture. We're finding chord lengths, missing chord lengths. We're finding x. So there was a theorem for this. It was the outside plus the inside. So the outside plus the inside chord, right, times the outside, right, will be equal to the outside plus the inside, right? Outside chord plus the inside chord times by the outside. Is everybody comfortable with that? So you have that theorem. So let's multiply this out here. So 30 times 3, right? 90. So we have 90 is equal to, and then we would have to distribute x in. So we have x squared plus 8x. Now you say, okay, I'm solving for x. Once again, this one's a quadratic. We have to make sure it's set equal to 0. So we subtract 90 from both sides of the equation. So we have x squared plus 8x minus 90 is equal to 0. Now we can solve this one, however, but if we can solve by factoring, that'd be good. But I can't think of factors that multiply to the 90 and add it to the 8. So we'll use the quadratic formula. Does that work? What? Because this is 90 right here. Then there was nothing over there. Are you good? Okay. So now you do the quadratic formula. X equals the opposite of b. So negative 8. What? 15 and 6? Oh yeah, let's factor there if it factors. Oh yeah, okay, that's a good idea. So we're looking for what multiplies to be negative 90 and adds up to be 8. You're right, 15 times 6, guys. That's a good point. Let's solve by factoring, because it'd be quick factoring, right? So we'll get our answer 10 times quicker. Okay, so it would be -6, right?
Yeah.
Right? Because that would add up to be +8. Oh, that's 9, huh?
Yeah.
Bummer. Maybe that's what I should do. Let's change the problem because I believe they will be. Maybe I'll change this to 9. Yeah. Are you guys mad if I do that?
Yeah.
You are mad? You'd rather go through and solve using the quadratic formula? Okay.
I'm good.
Okay, so I'm changing this to 9, this to 9, right? So this would have been 9. Are we all good with that? Okay, so then it would be -6 and 15. Okay, and I do believe that the ones on the test will solve by factoring. Okay? So anyways, but we could do the quadratic formula. Anyways, so we will factor this to be x plus 15 times x minus 6, set each of those equal to 0. So we'd get x is equal to -15. Can I skip? We'd set each of those equal to 0 and solve. And so we get x is equal to 6. We throw out the -15 answer, we keep x is equal to 6, right? Okay, questions on that one? Okay, so looking at this one, we're finding A. So once again, it's the same kind of thing. You say, okay, I have a chord and a tangent line, but it's making an angle on the outside of a circle. Now, do not mistake these for inscribed angles. Why is it not an inscribed angle? Because the angle was not starting on the outside of the circle and working its way out. Okay, everybody? So you'd say, oh yeah, I do have a theorem for that. Oh, right there. So we know the outside plus the inside times by the outside will be equal to the tangent line squared. So equal to 4 squared. Right? So then we distribute that in. We'll have a squared plus 9a is equal to 16. It's quadratic. We have to make sure it's set equal to 0. So we'll subtract 16 from both sides. So we have a squared plus 9a minus 16 is equal to 0. Okay, so then with this one, it doesn't solve by factoring, does it? So let's solve it using the quadratic formula real quick. So we have x is equal to the opposite of b, so -9 plus or minus the square root of b squared, so 9 parentheses squared minus 4 times a, which is 1, times c, which is -16, and that's all over 2 times a, which is 1, 2. So I'm just going to write 2. Is everybody good with that? So let's simplify that. So we have x is equal to -9 plus and minus. Tell me what's under the square root. Go.
81 minus 4.
So go 9. Make sure you type it in correctly. So 81. Oh, sorry. So you can just type it in exactly as you see it with parentheses. 9 squared minus 4. As long as you use parentheses, guys. 145. So we have plus and minus the square root of 145 all over 2. Now, because this is just, we're accepting decimal answers. Normally, if you were going to solve a quadratic, you'd have to go up to the side, break down 145. But the decimal answers are really what we want. So you'll type into your calculator. Now listen, make sure you type it in right. -9 plus the square root of 145. You have to hit enter before you divide it. Do you all hear me? -9 plus the square root of 145. You hit enter. Then you'll divide it by 2 because it's all divided by 2. So we get 1.5. And then -9 minus the square root of minus the square root of 145. Hit enter, divided by 2. That's -10.5. We throw that answer out, we keep this. Everybody good with that? Okay. All right, so looking at this one, find the value of x. So first of all, what are we given here? So first of all, let's think through this. Do you know what x is? 4. How do you know it's 4? So if this, well, careful. So think about it.
The arcs.
So the arcs are equal, right?
They have to be.
If the arcs are equal, then aren't the chords equal?
Yeah.
And if the chords are equal, won't they be equal distance from the center of the circle? So if this is 4, this is 4. Questions?
60, yeah.
Yep, so because they're equidistant from the center of the circle, this chord will equal this chord. Therefore, this arc will equal this arc. So this must be 60 degrees. Questions? Okay, you guys are doing really good. We're almost done here. These are the last 2 problems, and then you'll be good for the test. So find the perimeter. So first of all, it's the perimeter, but we're given a bunch of tangent lines on the circle, right? Remember, if you have 2 tangent lines that intersect at one point, then the tangent lines are equal. So if this is 10, what's this? 10. If this full length is 12, what does that leave us with for here? Well, if that's 2, isn't this 2? Well, if this is 3, isn't this 3? If this is 5, this is 5. Add up the perimeter. Now, here's what people mess up. They'll like mess up with something like this. So just go through and add up this so you don't mess up. What do you get? 40. So 40. Don't mess up when if you got that far and you mess up on adding up the sides, you'd be a sad person, you know? Okay? So if you need to, when you're going through and adding them up, cross them out so you don't double dip on something, you know what I mean? Or leave something off. Say, okay, I've added 2 in my calculator, I've added 10, I've added 10, 5, 5, 3. Do you get what I'm saying? As you go through, cross them out. Just be safe, okay? Okay, so it says, is the line that appears to be tangent really tangent? So we know that this is tangent, possibly. We'll make sure. But we know that if we drop a center down to here, the center of a radius down to the point of tangency, this would create a 90-degree angle, right? Well, if we have a 90-degree angle, then this is for sure tangent, but we've got to check. Is this for sure tangent? Because maybe it's not being dropped at a 90-degree angle, but if it was, wouldn't the Pythagorean theorem work? So wouldn't this be side 1 squared plus side 2 squared is equal to the hypotenuse squared? This is the hypotenuse, right? Don't say x, we know what this piece is. If this is 3, this is, so I like to write it out. My hypotenuse is 3 plus 2, which is, so if this is truly a right triangle, then 4 squared plus 3 squared will equal the hypotenuse squared, right? So let's check. If this comes out of true statement, it is a right triangle. Right? They work? Right, everybody? Okay, sweet. Oh, yeah, I didn't get them because we had test Friday. Thank you. Yeah, thanks. Okay, so this one worked, right? Now, if that didn't come out true statement, you'd say that must not be 90 degrees, otherwise that would have worked, okay? Okay, last one. Literally, oh, well, yeah, I'll make this the last one if you'd like. Okay, so it says, find the area of the shaded region. So first of all, isn't this, so area of the shaded region, right? So this is going to take a little bit of work. Don't we need to find the area of the sector, meaning this section of the circle? And then won't we subtract out the area of the triangle? So the area of a sector, so I'm going to go like this. Area of a sector, we know is theta over 360, right? So theta over 360 times by pi r squared, right? Let's figure out the area of that section. Now remember, the area of that section would be all of this. So we need to know theta. So 150, right? So this angle is 150. So we'll say, okay, our area of our sector is 150 divided by 360 times by pi times 4 squared. So let's write the pretty answer. 150 divided by 360 times by 4 squared. Change it back to a fraction. 20 pi thirds. Are we all good with that? Now that would be the area of that full thing if I shaded it in. So don't we need to subtract off the triangle? Now it's not a right triangle, so we know area of any triangle, no matter what, at the triangle, area of a triangle is 1/2 times side 1 times side 2 times by sine of the angle in between those two sides, right? So we would have 1/2 times side 1, which is, if this is 4, won't this be 4, won't this be 4? So times 4 times 4 times sine of the angle in between those two sides. Sine of 150, right? So 0.5 times 4 times 4 is 4. Okay, so we get 4. So we know the area of the triangle is 4. So won't you take the area of the full sector and subtract off the area of this? So you'll do 20 pi thirds. This one you'll have to get a decimal, minus 4. So 20 pi thirds, hit enter, minus 4 is 16.9. So the area of that shaded region is 16.9. Does that make sense, everybody?
Any questions on the test?
Oh, I don't know. I mean, like, there's different pieces to every problem, so it's hard to say. Around 25, but some of them are actually, well, let's see. Okay, don't forget how to find the area of a shaded region. Hey, thanks for coming, guys.